Alrighty, in this video, we are going to be doing more optimization problems. So for number 3 here, we are going to be looking at optimization dealing with, let's say, a point that's closest to the parabola. Since we're looking at a point that's closest to the parabola, we're going to be looking at, let's say, the distance formula. As a little visual here, I have y squared is equal to x in red, and I have the point 1 comma 4, and we want to see what point along this parabola right here is going to be closest to our lovely 1 comma 4. In order to do that, once again, we're going to have to use distance. So let's think about our distance formula. So we recall that our distance formula is going to be x2 minus x1 squared plus y2 minus y1 squared. And this is going to be our primary equation because obviously we want to find a point that's closest to 1 comma 4. So this is going to be my primary, which means that our secondary equation is going to be y squared is equal to 2x. Is going to be my secondary. And recall, just like how we did number 1 right here, we're going to use our secondary equation to solve for a variable so that we can substitute it into my primary equation. So looking at this, looking at our secondary equation, it's going to be easy for us to solve for x. So that's what I'm going to do. And then I'm going to plug that into my primary equation. So with my primary equation, I'm going to have now d is equal to y squared over 2 minus x1 squared plus y minus y1 squared. Now, you might be thinking, oh, well, we still have an x1 and we still have y1 that we haven't accounted for. Well, that is true. However, it does give us additional information that it needs to be closest to the point 1 comma 4. So that's what we need to use for x1, y1. We're going to be using 1 comma 4. All right. So we're going to be taking the derivative of this. Now, as a disclaimer, if I were to take the derivative of this, we're going to be using a lot of chain. So what I'm going to do is just square this and get rid of the square root. Because if I take the square root away, whatever this number is, whatever my critical point is, if I square it, it's still going to be a minimum. So we really don't care about the square root sign. I'm going to take the derivative now. And since we want closest to the point, technically what we want to find is our minimum. So that's our main goal. All right, so we're going to have 2 y squared over 2 minus 1. And then if I were to take the derivative of this, this is just going to be y using chain. And then I'm going to have 2 y minus 4. And then we're going to call it a day. All right. So this looks messy right now, I know, but what we're going to do is go ahead and set this equal to 0. So that's going to give us y squared over 2 minus 1 plus y minus 4. And then what I'm going to do is go ahead and distribute the y. So I have y cubed over 2 minus y plus y minus 4. Notice how now I have a negative y and a positive y. That's just going to cancel out. So I have y cubed over 2 minus 4. I'm going to move the 4 to the right side. So I have y cubed minus 2. Then I have 8 is equal to y cubed. So if I do that, this is going to tell me that I have 2 as a critical point. So now what I'm going to do is look at my, let's say, derivative here, where I didn't cancel out anything. And I'm going to see what happens whenever I plug in 0. So if I plug in 0, I'm going to get 2. Let's see, that's just going to be 0. And then if I plug in 0 here, I'm going to get 2, 0 minus 4, 2, negative 4, or negative 8, aka a negative value. And then if I were to plug in, let's say, a value, let's say 3, if I were to plug in 3, I'm going to get 2 times 3 times 9 over 2 minus 1, which is just going to be a positive number. Then 2, and then 3 minus 4, which is going to be negative 1, but that's just going to be a negative 2. Doesn't really change much just because this is a bigger number. So this is going to be a positive value. And if we look at this, we're going from positive to negative, aka we have a minimum. Crazy. So because we have a minimum, what we're going to do is go ahead and plug in 2 back into my secondary equation. So we're always going to most likely plug it back into our secondary equation here. And that's going to give us a value of, well, what is this? This is our y value. Oops. So let me plug it in into my y value, not x. So that's going to be 4 is equal to 2x. So x is equal to 2, meaning that my coordinate is going to be 2, 2. Now, if I were to verify this and look at, let's say, 2, 2 right here, you could probably see that it kind of looks like it's going to be the... Bestie, what did I do wrong? What did I do wrong? Oh, wait. Just kidding. This is 2x. That's why. Okay, just kidding. We're back on track. Yep, we have 2, 2. And as you can see here, from 1 to 4 and 2, 2, it kind of looks like it's going to be the closest distance anyways. Whew. So that was number 3. Lots of fun.